Okay, so I'm hoping you picked up fairly early that this was a really tough question to do because we had no f of x function. And I did go back to 1996 if I could, but couldn't. I don't actually have the 1996 paper. So let's leave that one out, shall we? Let's go to question 2. Okay, so if we just do a little bit of a division, we're going to end up with y is equal to 2x minus 1 on x. Yeah. So from our addition of ordinates knowledge, we know that both of these functions will offer us asymptotes. One of them at x equal to 0, and the other one along the line y equals 2x. All right. So there we are there. All right. So as you can see there, the first thing I did was actually put the graph on the CAS and plot the graph. So what can I see? Clearly the graph is going to have a local maximum here at x equal to 2. So it means it's one of these two, isn't it? Or one of those three. So negative 1/9 or negative 1/7 is, well, it's not going to be the minimum. So is it 1/7 or 1/9? And 0.1111 is 1/9, so 3a. 4 we couldn't do. 5, which of the following shows parts of the graph of? Now actually there was a little mistake in this. Tough question to do as well. That is meant to be x cubed plus 16 on 4x. So I think I've done two graphs here. Okay, so if you actually try to sketch x squared plus 16 on 4x, you've got that graph there. So I guess it's reasonable for you to try and pick C. Oops. To pick C out of that. Now, just pause the graph here, pause the video here, and work out the correct answer for x cubed plus 16 on 4x and come up with an answer for me. Obviously, if you put in x squared plus 16 on 4x, we have something a bit more like what we have on the right. And you can see there clearly that the answer is E. So, correct response E. What about question 6? Then the graph of 1 on f of x has asymptotes and minimums and maximums and things like that. So, biggest one in is here. First things first, we know we're going to have asymptotes when f of x equal to 0. So solve f of x equal to 0. So from memory, it's one of those things. So if we have a look at the calculator screen dump, if you've got the screen dump there on the right, we'll soon see that the function is equal to 0 at those 2 points, which means it's where the asymptotes occur, which makes it equal to b, doesn't it? All right, so again, we've got a function there. We want to know where the asymptotes occur. So what I've done is I put a way we could approach it is I expanded the function itself, and you end up with 4 on x squared plus 1. So clearly that's just 1 plus 4 on x squared, so it's a trunkus shifted up 1 unit, isn't it? So what does that mean? We have asymptotes, a single asymptote at x equal to 0, horizontal and vertical asymptotes. Well, it's not going to be x equal to 1, is it? So let's just concentrate on what it says. So horizontal asymptote up 1 unit, vertical asymptote hasn't changed. No turning points for a trunkus. All right, and you could check that with second derivatives and all the rest of it, but just even our methods knowledge should take us to C. Did the same thing for question 8. We expanded the function, and so we end up with 1 on 2x, so hyperbola, with the graph of negative a half x. So that's going to be a straight line asymptote, minus x minus a half x. So that brings these into it straight away. My hyperbola has an asymptote at x equal to 0. So that one there looks pretty good, doesn't it? Let's have a look. Find M&M has no vertical asymptotes if. So look, we could muck around. No vertical asymptotes means x squared plus mx minus n can't equal 0. Well, sorry. Well, it can't equal 0, but if that function there, if that's a parabola and it has no solutions, well then 1 on f of x won't have any asymptotes. So we want for x squared plus mx minus n, we want that to have no solutions, which means the discriminant has to be less than 0. So I get b squared minus 4 times a times b, c is less than 0. So we get m squared is less than negative 4n, which is D. Keep working straight along. Function blah 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 over its maximum has asymptotes at, well, even without sketching it, but we will. We have asymptotes at x equal to 4 and x equal to minus 2. And just from the knowledge, there's going to be a maximum. So x equal to negative 4 and x 4 and negative 2. So it's these ones there, isn't it? So let's get the graph and have a look for a turning point. Yeah, so you can see from the graph where the asymptotes should be at negative 2 and positive 4, and a turning point at 1.1111. So you just have to work out, is that 1/9 or negative 9? It's clearly 1/9. So we get E as a response there. Okay, what have we got here? Possible equation of the graph of the curve shown here is, all right, so again we've got x squared as an asymptote, an oblique asymptote. So we should end up with a x squared plus something. Okay, now our graph is symmetrical, so this is going to give me an x squared plus a on x. What I'm looking for is an x squared plus 1 on x squared. That way we get symmetry about that vertical axis. So we're going to end up with one of these three things, aren't we? So a simple way is to, again, just sketch them. So you'd think, well, I guess we can eliminate c, because if we do the division there, I'm going to get 2x squared plus a on x squared. And so 2x squared will be my asymptote as opposed to x squared. So it's going to be one of these two. Is a positive, a negative? Let's just plot them. So I've added the three that I thought were feasible. X to the 4 minus x squared, you can see the significance of the negative sign there. So a is not going to be less than 0. So that really leaves you with c and d, the 2x to the 4 and x to the 4. And they both seem quite reasonable, okay? But again, the key point is this one here would give a 2x squared as the oblique asymptote. So it's got to be x to the 4 plus 1, or plus a, where I've varied the a. So, and I think that's a really good process. Just put in some values. It just says a is greater than 0, so put in a plus 1, plus 2. It's just going to shift graphs, isn't it? Okay, question 12. We'll represent a circle. So obviously we're looking to complete the square a little bit here, aren't we? So I think, what if we use our CAS to do that? So if I can type that in and complete the square, you see that we've got this expression here, and that thing there, take it across to the other side, that's my radius. So for this to be a circle, a squared minus 4 on 4 has to be greater than 0. So look, we probably could have worked that out outside of that, but a squared minus 4 on 4 has to be greater than 0. which means a has to be less than negative 2 or a has to be greater than 2. So there we are with E. The graph of the function with the rule y f of x equals 2x minus 1 on x squared has... Okay, so again, it's something we could easily sketch. And again, I hope we're starting to get a feel that my 1 on x squared's got my one vertical asymptote at x equal to 0. 2x is my oblique asymptote, and you can see the graph here, the line y equals 2x, I just popped it in there. You can see how the curves approach that. So we're going to have two asymptotes. I've got a maximum value here at negative 1, 3. Sorry, negative 1, negative 3. So two asymptotes, negative 1, negative 3. And again here, look, there's the little distractor there, isn't it? Okay, just getting your turning point. So I guess your decisions are how many asymptotes, where's my turning point, that sort of thing. All right, f of x equal, k is an odd integer which is greater than 1, a less than 0, possible graph could be. I'm going straight to the calculator and putting that in. I'm just going to put k as an odd value. I'll put a as a value less than 1. Okay, so I might put in x to the 3 minus 1 on x and have a look at that. Check it again with one of the other ones and just see if it changes much. So with other values, I mean. And you can see there, I've just picked three different forms. I've put x as 3, k as 3, and then a is negative 1 and negative 3. And you can see all the graphs are relatively similar. And it doesn't have to take a long time to put these functions in. All I did was define f1 of x equaling one of the functions and then copy and paste it down. Copy and paste it down, change the 3 to a 5, had a look to see how it looks like. So they all have basically the same sort of shape about them. And what's that going to match off to? It looks like it matches off to D, doesn't it? No, not D, sorry. A. Matching off to A. Yeah? So use your CAS.